Figure below shows a velocity time graph for a journey lasting 65 seconds. It has been divided up into 6 sections for ease of reference. Using the information from the graph, obtain the velocity 10 seconds after the start. So 10 seconds after the start, the velocity is 20 meters per second. The acceleration in section A. The acceleration is given by the gradient of the velocity time graph, so the acceleration will be 2 meters per second square. The acceleration in section E, so same thing, acceleration is given by the gradient of the velocity time graph, so we'll get a negative 7 meters per second square. The distance traveled in section B is given by this area under the graph. So this is a rectangular section, so we get 300 meters. The distance traveled in section C, so same thing is the area under the graph. This time it is a trapezium, so it's half times sum of opposite side multiplied by the height is 250 meters. Describe qualitatively in words what happens in section E and F of the journey. So at time equal to 50 seconds, the object decelerates uniformly at the rate of 7 meters per second square from 20 meters per second until it reaches an instant, come to a rest at around 54 seconds. And then after that, it moves in the opposite direction. And the speed increases, so it is accelerating at 7 meters per second square until it reaches a speed of 5 meters per second at 55 seconds. It continues at the uniform speed of 5 meters per second in the negative direction for the next 10 seconds until time is 65 seconds. Sketch the shape of the corresponding distance time graph. You are not expected to make detailed calculations of the distance traveled. So section A is a constant acceleration starting from 0 velocity. So it looks like that. It's a slight curve. Section B is a constant velocity. Therefore, it's a straight line graph. Constant velocity is the gradient of the distance time graph. Constant velocity gives a straight line graph. Section C is a constant acceleration. So like A, there will be a slight curve upwards. Section D is a constant velocity, so it's a straight line graph again. Section E is a constant deceleration passing through 0 velocity. So 0 velocity, that is when the distance time graph is horizontal. So section F is a constant velocity, so it's a straight line graph again.